Okay, mathematical induction. First one is a proof of inequalities. First question, show that 1 plus y to the power of n is bigger than or equal to 1 plus ny, where n is belong to natural numbers, which is all positive integers, and y is bigger than -1, and y is belong to r, which is real numbers. Okay, step 1. I'm going to go prove true for n equals 1. So when n equals 1, I'm going to put all this into 1 here. Power of 1 plus y, which is same, which is a part of that. So therefore P1 is true. Okay, so that wasn't too bad. Step 2. Assume true for n equals k. Instead of n, I'll just put it, replace with a k. That's all I'm going to do for step 2. And then step 3. Prove true for n equals k plus 1. So I'm going to go 1 plus y to the power of k plus 1, 1 plus k plus 1 y. Okay, so left hand side, which is this part, that's 1, and I'm going to separate these two because I want to use the step 2. So 1 plus y k. Okay, now from step 2 here I can use that one to this one, so I'm going to go 1 plus ky because I'll replace that one to this one from step 2. Now here sometimes we need to change it to bigger than or less than, but because it's got equal to, I'm just going to keep it as equal. Okay, it's not a big problem here at the moment. So I'm going to expand this one. Okay, and then I'm tying it up. I want this to be look like this. Okay, so I need to tighten it up this one. It looks like this. So I'm going to use different color. Plus 1 plus just keep it up with the same, because that is this one, and put 1 there. So this definitely is a bigger than what it is, isn't it? So that's bigger than. Okay, which is my right hand side. So therefore we can say is true, but when it was 1 is also true, wasn't it? And then the other middle one we assumed that it was true. So therefore step 4 we can say P of n is true by mathematical induction. Okay, all done. So second question. Alright, so we've got some factorial happening here. Oh, it's not too bad. So I'm going to go with the step 1. Prove true for n equals 4. Okay, the minimum integer we can use is 4. Okay, so you just use that. And P4, 4 factorial. 4 factorial is what? 4, 3, 2, 1. Okay, and then 4 times 4 times 4 times 4. And you use your calculator, whoops, sorry, calculator, you'll get 24/16, which is true, so therefore is true. Okay, and then step 2 here, assume true for n equals k, and I'll just replace n with k. That's all. And then step 3, prove true for n equals k plus 1, and I'll just replace it with k plus 1. Okay, now I'm going to go left hand side, which is this part. I can write this in k. Remember, 5 factorial, you can write as 5 times 4 factorial. Okay, you can do that. So in this case, I'm going to have to replace it this. K factorial is bigger than 2k. So I'm going to replace this k factorial with 2k. Now what happens if I do that? It would be now 2k is less than k factorial. So it has to be less than, isn't it? Because we're using less number here. So what happens here now? This is the part you have to be very careful about. Okay, so you might think, oh miss, what happened here? We put in k equals 1. Now what happened is, as k is, from the question, we know that k is bigger or equal to 4. Okay, and k is also belongs to natural number, which is the positive integers. Now because this part is a less than k, we can use all the k is a less than 4, which is 1, 2, 3, 4. Okay, and it's the smallest number we're going to use, because if I use 4, 5, 6 something for k, that is not going to be satisfied, because that has to be then bigger than, not less than. So just be careful and put that in there. So now I can do, which means is the same as this up there. Okay, so therefore we can say left hand side is bigger than the right hand side, and therefore pk plus 1 is true. And but p of 1 is also true. So now step 4, p of n is true by mathematical induction. Okay, well done people.